That's fine. There we go. Yeah, you're on.
Welcome to the last seminar of the winter quarter. Today we have Mr. Craig Dewey from Federal Highway Division, Western Federal Lands, to present on context-sensitive, multidisciplinary design of historic roads in Western National Parks. So with that, it's all yours, Craig.
Okay, thank you. As he said, I'm Craig Dewey. I work over across the river in Vancouver, Washington, the Western Federal Lands Highway Division of the Federal Highway Administration, and I got a BS degree in geological engineering in 1976 from the University of Utah, and I've done graduate study in pavement design and management, foundations, and soil mechanics with several different universities across the country. So my background is primarily geotechnical engineering, and I've been doing that for about 26 years until the last 2 years I took on a project management role in our office, and I've been managing the projects the last couple of years. And so I've basically got 28 years on multidisciplinary teams, working both as a team member and the last couple of years as leading the teams. The Federal Highway Administration kind of has two branches. There's the federal aid side, which delivers most of the funds to the state highway transportation departments that are used to build highways within the states and the like. And then there are three federal lands highway divisions that are actually construction and project oriented, that deliver projects on federally owned lands in the U.S. So you got national parks, and other programs. And those three offices are in Sterling, Virginia, which covers the eastern seaboard mostly. The Denver, which covers central federal lands, covers much of the middle part and southwest of the country out to Hawaii. And we have a small area that's geographically, well, actually it's about, I guess, a third of the country, but it's about a third of the dollar value of projects as well. And we have Alaska, Washington, Oregon, Idaho, and Montana, and then the two big parks, Yellowstone and Grand Teton, in the northwest corner of Wyoming. And about 40% of our project work is in the National Park Roads program, and the rest of it primarily is in what they call the Forest Highway program, which is main highways going in and out of the national forests. And our office, along with the Forest Service regional offices, and usually a state secondary roads division, manage that forest highway program and determine where the funds would be distributed. And as far as the park roads program, the regional offices of the Park Service determine, basically do the programming of projects and determine which projects we'll work on. Did you have a question?
Yeah. What's the secondary state highway roads program?
Usually there's primary federal aid highways that are the major routes, the interstates, and things like Highway 26 going out to the coast. But when you get down to smaller roads that are managed by the states or the counties, that's usually considered this kind of the secondary part of the highway system, and that's usually each state DOT has someone that kind of manages that smaller part of the DOT program. We also have a few, it's a very low dollar value, Fish and Wildlife Service projects scattered around the Northwest on little Fish and Wildlife Service preserves and fisheries and the like. And then when there's a big flood like we had in 96, 98, or St. Helens back in the early 80s, we also manage the emergency relief program and do the work ourselves, or hire consultants, or have the Forest Service, whoever, do the work to repair those. And then there's a small amount of defense access roads. We gravel, county roads out in the middle of Montana that lead to the missile bases out there, and then the Bureau of Indian Affairs actually gets about 40% of the dollars nationally that are provided through the Federal Lands Highway Program funding. And but that's managed directly by the BIA, and so there's basically just one person in our headquarters office that's involved with transferring all that money to the Bureau of Indian Affairs, and they manage it and manage their own road program. And our funding comes from the gas tax. It's usually, Federal Lands Highway Program nationally is somewhere around 600 to 700 billion. If Congress passes the highway bill that they've been working on, they're looking at somewhere around $1 billion a year funding for the Federal Lands Highway Program across the country. The cross-functional teams. When we develop a project, and I want to kind of concentrate the rest of the time now on the Park Roads program, because that's what I wanted the main talk today. The cross-functional team kind of applies primarily to the people within our own office, but when you start looking at the Park Service, when we go to work in a park, the park usually has some people on their staff that we get involved with. They have kind of a contracting sort of group out of Denver called the Denver Service Center that provides specialists in wetlands or whatever who can go out and do the wetland delineations, or archaeologists. Actually, they have a place called the Midwest Archaeological Center where they have a lot of archaeologists stationed that go out and do the cultural resource surveys for the projects. And they also have biologists in the parks and there. And then the region is, we work with 3 regions, one out of Denver, one out of San Francisco that covers, Denver basically has Montana and Wyoming, Idaho, Montana, and Idaho, Oregon, and Washington are handled out of San Francisco, and then Alaska is its own region by itself. And so typically our cross-functional team or our multidisciplinary team will have people from all of these different areas, different facilities on a project. And this is an example on one case over in Yellowstone. We're looking to build a new alignment across the river here, and the new bridge will fit right between these 2 rocks. It's just wide enough to fit between these 2 rocks, and so that'll give it a lot of interesting character as the road goes right between this little notch between the rocks. And you can see there's quite a group of us, and when you start looking at all the different people, typically in the larger parks like Yellowstone, Grand Teton, Glacier, Mount Rainier, they have a large enough staff that they have all the specialists themselves, so we work directly mostly with the people from the park. In smaller parks like Craters of the Moon, Glacier Bay up in Alaska, Denali, the Denver Service Center gets involved more, so some of those people might be part of the team. And for most parks, we've got wetland specialists. We have to do the wetland delineations around the project to make sure that if we do impact wetlands, that we replace them, in kind, somewhere else within the park. Cultural resources, both historic cultural resources that in some cases tie in with the roads or buildings, and then the prehistoric resources from the indigenous people that lived here earlier. Rare plants, usually have a botanist that's a member of the team, or like in Yellowstone, we have one woman who is the wetlands biologist, and they have a road team there that's 5 people, and she brings in all of the natural resources, the geologists, the botanists, and all that work. Threatened and endangered species, the biologists, mammals, birds, and the like. And forgot to mention, like with the archaeological resources, those people also take care of the consultation with the state historic preservation offices, and the biologists work with the Fish and Wildlife Service or National Marine Fisheries Service to get approvals and coordinate with those agencies to make sure that we're following their procedures and get clearance from them to make sure that we're following the laws. Well, usually landscape architecture is very big in the Park Service, and so we always are involved with maybe one or maybe more landscape architects on a project. And then typically an engineer of some sort that's involved with the maintenance of the roadway system. And then in Yellowstone, which has all the thermal area, that we also do thermal resource studies, and we've taken where we're developing now, where we actually fly over the area using thermal infrared photography and tied in with the GIS system, and allows us to overlay, just like all the other resources the Park Service uses a GIS system. So they're in multiple layers within their GIS system, all this information that we just bring right into MicroStation. And so our road alignment is played right on top of all the different resources that are mapped on there. In the national parks, and this is kind of Craig Dewey's spin on what context-sensitive design in the national parks are, having worked in the parks for about 16 years now. And the key, I think, to a successful project is learning to understand the park's values, and so that you can mesh your project into whatever the park's values and what's important to them in that area, and so you have to work very closely with them to understand their values, so you can set the context for which the road is going to work there. And so, in understanding the values, we learn that from the park representatives who are on the teams. We also get it through the public involvement process. Park foundations, many of the larger parks have a group of people who have created a foundation to support the park, and they do fundraising, and some of their money goes into some of our projects, and it's usually coordinated through the parks. And then also any kind of feedback we get from interest groups help us to direct and develop the context. And a good example, I think, of how that worked is up in Glacier Bay on a project we did a few years ago there. This was kind of a one-shot deal where we came into the park. They have a 5-mile road, and it was scheduled to be reconstructed. And we'd never worked with any of these people before, and so there's building rapport with the people is something that's important. And in this particular case, we sat down the first day, and the park superintendent, which was kind of neat to me. I've been working in Yellowstone a lot of years, and we maybe see the park superintendent once or twice a year. With a staff of 800 to 900 people, they've got a lot of business and other things to deal with. But when you go into a smaller park, you typically do meet right with the superintendent. And sometimes they're happy to see you, and sometimes there's a little bit of intrepidation because they've not been involved in this process before. So it involves a lot of education. And when we started looking at this project, if you look clear down in here, Glacier Bay comes over this whole area here, but down in this corner is the only place where there's a road. So basically, what does the road serve here? There's a little visitor center there. There's a dock. There's an airport there in the town of Gustavus that was actually built by the Air Force during World War II as one of the stopping points for getting materials into Alaska out to ADAC and supporting the war effort. And that landing strip is very unchanged, relatively unchanged from what it was built there back in the early 40s. And when you fly in there, and so the visitors fly in on an airplane out of season. Alaska flies in there with one big flight a day. Off season, you fly in and out of there on charter planes. So you drive out the road to the park. There's a little visitor center. There's a small lodge, an excellent restaurant, and then you get on a tour boat and you go out and travel up and down the arms of the bay here and look at the glaciers, watch the ice calving off. There's lots of wildlife. You see whales, mountain goats, bighorn sheep, grizzly bears. And so, the context here then is that the road actually is providing access to the dock. So your visitor experience really doesn't start till you get on the boat and out in the dock there. But the road is important because that's the first thing the visitor sees. And so that kind of helps us set the context. And the park superintendent, started out the meeting by giving us his vision for this project, that this is the first thing the visitor sees when they come into the park, and it needs to be a pleasant experience for them to drive through the road and safely get down to the dock and go out and see the rest of the experience. There's a lot of interesting things, and you could go on and on with any of the parks here. When Captain Cook came here in the late 1700s, this whole area was covered with ice, clear out to the point here. So this area where they've developed is only 200 years out of the ice. And so there's not a lot of historic context in the area, other than the fact that it was ice coming off there 200 years ago. But so the road system in there isn't historic, but there is historic usage by the Alaskan natives. So we do have to do resource surveys for that. So the road system in this park isn't historic. And then this is what you see when you get down to the end of the bay, and these big piles of ice calving off. And I talked a little bit, about building rapport and trust, and so that's a real challenge in the new parks where we go in. So that's an important thing in working with the people to develop that rapport and trust. The bigger parks where we've been working a long time, we have the same people going in and out of there all the time, and we've pretty much got a system. We actually did some formal partnering in the early years, and so we've got our road team here that we're working with, and that's an important factor of building that rapport so that you can communicate all the issues and information back and forth with each other. And then the next key when you actually get out and you start developing a project is listen, because basically everything that we put into a design has to come from somebody else. We have to listen to all the different specialists. Typically there's conflicting issues, and the context varies from park to park, and it varies from location to location within a particular project. The cultural resources may be important in one area, the wetlands may be important in another area, and in many cases they're overlaid on top of each other. Typically in thermal areas we also have wetlands and rare plants associated with them. So sometimes it becomes a trade-off between one resource and another, and that's not our decision to make. That always falls under the purview of the Park Service because they're the land managers, and so we do the engineering for them. We're their consultant, but they make most of the decisions. And it's a formal partnership. And here we have the archaeologist providing us some information on one of our meetings. And then the key to a successful project is once you have all the information, and this is always an iterative process, that we gather a little bit of information, which leads us into some decisions to start moving ahead a little bit farther. We gather more information, and we keep coming back. And so it's always an iterative solution in doing a park project. And the key is to use creativity. Standards are important, but knowing what's behind standards and what is more critical in one area or other. The Park Service has their own standards that are derived from AASHTO, but usually they're more associated with a park environment, and clear zones sometimes are narrower or often narrower with park road projects than they might be on a state highway. In this particular case, we had a bridge in Yellowstone there. We widened the roadway. We left the piers unchanged. We basically took the deck off. We widened the abutments, and where the piers stuck out from the edge of the bridge before, the bridge now that's widened out to 30 feet. Originally it was 24 feet. It now kind of overhangs these piers, but we constructed the bridge on top of the piers, designed it to current seismic standards for about 0.3 G earthquake acceleration we use in Yellowstone. And we dismantled the abutment walls and rebuilt them wider, and we used stone conserved out of the cuts to reconstruct the stone walls there. So basically we matched the previous stone work. There's acid, it's acidic water here, so the stone had deteriorated over the years, and so we built this stone kind of footing or support, because the piers were actually pretty badly undermined by the acid taking the stone away prior to that. So defining the context is important part of developing a job. And when you start talking about historic roads, in Yellowstone is one example. The road system was started, about back in the 1870s or so. The Army actually ran Yellowstone for the first 40 years of its existence, and the Park Service took over in about 1912. And so the Army was involved in a lot of the early road construction, and then it went on to the Park Service, and then in the 30s, under the CCC, Civilian Conservation Corps and Work Progress Administration days, there was a great deal of work done through private contractors, but the engineering was done by the Bureau of Public Roads, working closely with the Park Service landscape architects. And that the BPR is the precursor of today's Federal Highway Administration. And as transportation modes changed, the road systems needed to change to fit the transportation modes and provide the greater access. So you have stagecoaches early on, and then you have larger and larger cars, and now we have RVs and pulling Humvees, and that creates difficulties. In the early days of Yellowstone, a lot of the access was by railroad terminal to Gardner. You've got they call it the Roosevelt Arch over here in the corner. It was constructed in 1903, and Teddy Roosevelt came out to for the ceremonies for that, and that's why they call it the Roosevelt Arch. But people would get off the train, ride stages back into the park, and then later on, use cars to go in and out of the park. But there's always been a pressure to build the roads bigger. Oops. You got the stages, and there were actually camps. A stage ride every day's a stage ride. Scattered throughout the park. So the people would spend a week going through the park, take a stage to the next camp, and they were usually tent-type camps. And these were mostly people that were pretty well off and could afford to take a 3-month tour or something around the country. And some of the early roads, some of the early road construction work, oiling the roadway, and then one of the buses that was kind of ubiquitous through a lot of the big parks, Mount Rainier, Glacier, Yellowstone during the 30s and 40s, giving people tours around the parks on the improved roads built through the CCC era. And something else that ties in with this, one of the things that, the park's mission is to preserve and protect the resources in the national parks. And this is often at cross purposes to road construction and visitor access. And that's the other part of their vision, is to provide access to the visitors to see these resources. And those are often at cross purposes. And so that's always a factor in developing our designs. We're trying to balance many different resources, different concerns back and forth against each other. Wildlife is also a key factor in many of the parks. Most of the parks are preserves. They don't hunt there. They reintroduced the wolves to Yellowstone a few years ago. The bison get in the roadway, and this is part of the thing, is that you can design, if you've got some sort of a viewpoint or whatever, there's a big panorama or there's a falls or something, you can build a pull-out, people can get off the road there. The wildlife, or wherever the wildlife happened to be, and the people stop wherever the wildlife happened to be to look at them. With the 24-foot road system that was built in the 30s, it basically becomes gridlock. There's several mile-long backups of traffic in different areas where the wildlife congregate. And so the park road standard in Yellowstone, they're looking to go to 30 feet wide. that gives room for people to pull off the shoulders. We also have high traffic volumes, 8,500 ADT on the highest parts of the park roads. It's a seasonal ADT. There's nobody there in the wintertime. There's a few snowmobiles. And this is some of the results of that. This is the Gardner Road. It's 26 feet wide, I think, this piece. And so the new road, the wider road system that we've been reconstructing the roads in Yellowstone to, we've done about 70 miles of reconstruction and 90 miles of overlay work in Yellowstone since 1988. A little too far. Also have wildlife in Glacier. Glacier has one main highway going over the pass. It's about, I think it's 45 miles long. It's been a lot of years ago since I last worked in Glacier, but you have the wildlife there, and you could argue that maybe you should make it wider for people there, but when you look at the context of where Glacier sits on this hillside, it's very narrow. You got high rock cuts. There's a lot of retaining walls. The decision was made in Glacier to limit the types of vehicles that use the road. So nothing over 24 feet long is allowed to go over the Going to Sun Highway. And because it would be too expensive and too impactive on both the historical character of the roadway as well as the other park resources to widen the road there. And so the decision has been made, and that's the context in Glacier, is that the road is basically being reconstructed to the same template it is now, and much of it is the work that's done there is primarily repairing the walls, which are very extensive and it's very expensive, and then rehabilitating the highway surface, the pavement surface. In Glacier, in Denali National Park, their vision is to be the primitive, natural park of the Park Service. And so you've got Mount Denali there. You have a 90-mile long road that runs out into the park, but you're limited. They actually, through their EIS and their management process, they've determined that they aren't going to allow any more than a certain number, and I don't know what that number is. I've never actually gotten into Denali yet. But they only allow so many trips back on the roadway in a given year. And that includes park maintenance traffic, any administrative traffic, any research activities, and then most of the visitors ride in and out of the park in shuttle buses. There's no private vehicles allowed in the park, with the exception of 4 days at the end of the season, and that's done on a lottery basis to allow people to go in and out of there. And the road is narrow, given that you don't have only the first 15 miles are paved. They're not looking to pave the rest of it because you have not a lot of traffic on the roadway. You don't have a lot of the transportation engineering issues that you maybe would normally be looking at, and where you have a lot more traffic. And so there's a very different sort of context in doing the road construction work in Denali. And so much of our work is in smaller projects that are involved with improving the surface, dealing with landslides. This case up on Polychrome Pass, that's also a kind of a thing that we only get in Denali as kind of another context or issue. There's a landslide here in this location that's a big ice wedge under the ground that's melting and thawing away, and the earth is settling underneath it. So it's always changing, and that's why it's really important in working in each park to work closely with the staff and understand the issues that really apply within the context of that given park. When we start doing a project, most of the historic routes and historic highways are primarily in the big parks that had construction done during the 30s. It's Mount Rainier up in Washington, Crater Lake in Oregon, Yellowstone in Wyoming, Glacier in Montana, and a few smaller parks scattered around in our area there. And because of the impacts, we don't normally want to leave an alignment unless in doing our reconstruction work or upgrading a road system, we don't want to leave the existing alignment because of the impact associated with creating new alignments. But if there's a good reason, because the road is already impacting negatively on a resource in a given area or something like that, going back to the mission to preserve and protect, if that road is negatively impacting a resource like a thermal area or something like that, or wetlands, or we can maybe get some wetland benefit. We can restore some wetlands that were originally taken out by the roadway by moving the alignment a little bit, then we'll do that. And one of the things we try to do is to lay the road lightly on the land. And so that's why in a lot of cases, most of the parks have a 45-mile-an-hour design speed maximum. And there's, in sensitive areas, that may be lowered down to 35 or 25. And so it is a different kind of an approach to a highway than it would be maybe in an urban environment or a more typical rural sort of environment that might be similar to a park situation. The curvilinear alignment allows the road to fit a little lighter on the land. You do less excavation to get the roadway on there. This is a more recently constructed project and to a 30-foot wide road standard, but you can see that it still has a very curvilinear alignment. There's not a lot of impact or movement away from the original alignment that was constructed in this location. And another reason for doing the curvilinear alignments is it allows us to avoid resources. And so when we're doing design work on a project, we may go through as many as a dozen, 15 iterations in some areas. We throw an original alignment. When we first do a project, we'll drive through the project. We know there's wetlands, that are obvious in some areas, or thermal areas, or some nice big trees or something that we wouldn't want to impact. So our vision is to shift one side or the other to avoid those things, but then when we actually get into the design, those are on our plans, and so we spend a great deal of effort tweaking the alignments back and forth to try and miss as many of the resources or whatever is important to us in a certain site.
Are you taking questions?
Sure, I'll be doing them at the end too, but if you get something.
Yeah, I did. Mike, there? Hi. Oh, there's a webcast.
Hold down the button.
I was wondering. The AASHTO design standards that we've got to meet. For safety, they usually want to have straighter alignments. I work at ODOT, and so we get the design engineers hung up with wanting to straighten everything out and make it safe. So it sounds like one way you handle that is by reduction of design speed, so you can have more curves. Do you also often have to get design exceptions to be able to do the curvilinear alignment? And does Federal Highway generally support getting those design exceptions for this purpose?
Yes, and kind of yes. For every project, we do an evaluation of that, and we do have a design form that we go through that lists the standards that we're using on any particular route, whether we're, and we have to go through, the park road standards typically deal with width and curvature and of curves and alignment and the like, maximum grades and the length of your vertical curves and the like, and those but they leave out some of the stuff as far as like curve widening. If you've got a fairly narrow roadway and your design vehicle is a bus or something like that, you have to check for that. So we typically use AASHTO, but there's a lot of judgment that's applied to it because there are resource impacts, and so and the same thing applies with guardrail warrants. The AASHTO roadway design guide may recommend guardrail in a given position, but one of the things we'll look at in the question in evaluating whether we should put guardrail or not, typically if it's already there, we'll put it back. But we do need to evaluate that along the whole alignment, and so we do that evaluation. But we look at what the accident history has been in those locations, and if there isn't an accident history, then that gives us some comfort that it's maybe less of a concern there. And we typically with the wider roads, we do have a minimum of about a 6 to 7 foot clear zone on most of the alignments. So when we do have design exceptions, and clear zone isn't a design exception, but when we do have design exceptions either in the super elevation run out or the length of a spiral or the tightness of a curve, we document that, and then we document what actions we've taken to try and whether we signed that or because if it is we do follow AASHTO as far as the signing, as far as putting up curve signs and the warning placards on the tighter curves. And if it is an area like on Dunraven Pass in Yellowstone, we built that only 24 feet wide, and the design speed is only 35 miles an hour on that route because it's a very mountainous route. So the curvilinear alignment to a certain extent tends to keep the speeds down. People tend to drive slower in the parks, and so it's kind of complementary, I think, the alignment and the safety. Slope sculpting is something that, is kind of recently we've developed, in the last 10 years in the park. When, they're originally constructing the roads in Glacier or wherever, they used a lot of black powder. They used a lot of what they call lifters, where they just drill big holes back into the hillside and load them up with powder and blast the rock as, we call it air haul, where the rocks fly across the air to wherever they land. And obviously that's not acceptable in the construction that we're doing these days. And so we've modified our controlled blasting techniques, opened up the spacing. We load our production blasting very lightly, so we just fracture the rock, and then we try and cut the rock back to a more safe angle of repose. But the other thing, too, is if in a normal highway construction, you're trying to limit as much, and this seems kind of counterintuitive in a national park, and it took us a while to get the park to go there. But, if you stand the cut as steep as you can go, you're going to have the less impact on the ground. But if you stand it as steep, it won't revegetate as well, and as you go around the curve, you've got this steep rock cut. It has no variation to it. It's just this big rock wall as you go around the corner, something that might look like this one. This is one of my early jobs in Idaho back in the mid-'80s, and so where you've got this nice pre-split cut. And so something we developed, and it actually takes up more impact, but it really ends up with a much nicer product as far as visually pleasing to the eye. So I'm going to go through a series of cross-sections here. In the first one, you've got a soil slope transitioning into a rock cut. And as you get in there farther, into the slope, you start making contact with the rock slope. And so you can see the steep section and the cross-section there where you're picking up the rock in the cut. But understand that down lower it's still rock, and so you're cutting rock to get the flatter slope down on this lower portion of the slope, because you're cutting rock all through this area. And you get more and more rock, and then to the last cross section, and this is tied in with the curve. So as you get deeper and deeper into the curve, where you get right into the center of the curve is where we're trying to steepen the slope the most, so that it kind of keeps the road, the cliff coming out to the roadway as you go around the corner, and this gives you kind of a peekaboo sort of a thing as you go around the curves. That each time you go around a curve, you're opening up a new vista. And then with a center cut there like that, and this is a good example of that treatment here, where the rock face is coming back away from the roadway. Instead of having that rock face right here all the way around the curve, it's pulled back on the edges, and we have this slope here, which is rock underneath that we've hauled topsoil and soil on top of, and placed the curve. And this is it looking back in that same location. And this is kind of the construction technique I was referring to earlier, where you've got the excavator. We blasted this cut, and we fractured the rock, but the last fracture back to the joint is done by pulling the rock away with the excavator and going back to a good, naturally stable rock face that's controlled by the geology of the rock itself in the structure of the rock. And a lot of times they'll use a ram hoe with a hydraulic pneumatic hammer on the end of a excavator to be able to break the rock back to those faces. And something else that ties in with that is that we're trying to do two things. We're trying to bring the cut slope in and out of the roadway, so there's some variation, so you don't have this uniform slope going along the road all the way. But then there's also a smaller variation that's just within the rock itself, where you're breaking on the fractures. So you can see the rock faces in this cut, and then you can see some more variation where the slope is going back and forth away from the roadway as well. And it's a little more dramatic in this one, so you can see that. And topsoil vegetation management is real critical in the parks. We don't want to introduce a lot of exotic plants into the park. We want the natural fauna to be growing, or flora, excuse me, to be growing there. And so to manage that in the parks, we clear the topsoil off. We windrow it right at the top of the cut. And we don't haul it down unless we have to, and we do that in some cases, but we keep track of where it came from. We move that up to the back of the cut, and it's topsoil there, and as you bring the cut down, then you bring that topsoil back over the finished slope of the cut. And this way you keep the natural seed source is right there in the topsoil, so it goes back on the, you have rhizomes and then bacteria and the like that are appropriate to that topsoil material. So you're bringing back the natural material right in the same place, right in the same environment. And so they bring it down, and we throw some landscape logs on. The landscape logs create a kind of a microclimate for plants to grow, and then we use a bark mulch that we put over it that's not acidic. We don't use fertilizers because that usually tends to bring out a lot of grasses right away, and you don't get the other shrubs and the like developing. And so this is a wetter area 1 year after we brought the topsoil back. This is a couple of years later on this project, and you can see the landscape logs on the hill here. They're tied down with stakes into the ground, and they create little microclimates, little shaded area where plants can grow. And so you can see the logs here, and you can see how the the shrubs here, little flowers are growing in the shade of the tree. So they create little microclimates that allow the plants to get established and start growing and spreading from that location. So this is something we work real closely with the landscape architects on. They do collect some seed, and when we're out working on the project, if there is a nice specimen or something like that, we will use the tree spades and transplant some trees as well. But usually the seeding and planting is done in a specialized area. We've got one project coming up where we've got a couple of miles where we're going to be pulling a roadway out of a stream, from along a stream, putting it up on a ridge, and we're going to be reestablishing the stream channel there. And so we need something that's going to revegetate a little bit quicker, and so we're growing we've collected the seed, we're growing them in greenhouses within these coconut fiber meshes to go out and lay on the ground there next to the stream so we don't get erosion right into the stream when we reconstruct it. And I'm starting to run a little bit over, but I did have a question or two in there, so I'll try and finish up quick with the historic structures. Because I think that's a key thing as far as historic. When we do the cultural evaluation, the archaeologists and the cultural resource specialists, they have to do what they call a cultural landscape inventory, and they look at all the history of what was developed there. And they, like with the Yellowstone, the Grand Loop Road in the Yellowstone that makes a big loop through the park, it's a National Historic District by itself. And certain of the structures are contributing to that historic nature. And so you have to take that into account and make sure that you reconstruct the bridges as close to, or the retaining walls or whatever, as close as possible as you can in trying to maintain that historic context for the roadway in any work you do. And like I mentioned before, in Glacier, it's mostly a repair kind of a thing, and there's miles and miles of retaining walls in the park there, and they were built obviously up from the bottom up, but they tend to wear out from the bottom up as well, and so it gets pretty hairy in trying to reconstruct these and repair them, and yeah, a lot of times you have to do a top-down kind of a thing to do that. So in this case here, they're actually installing some tiebacks back into the slope and anchors, dowels that are grouted in there to tie the whole retaining wall and slope together. And then something else they do a lot of work on in Glacier is they go in and clean the grout out as deep as they can get back in between the rocks, and they're putting new grout in there because the old grout is weathered and coming out. So there's quite a involved sort of a thing, and to do this work we have an inventory, the entire retaining wall system in Glacier National Park, and we know where the worst areas are, and the programming for the projects is really pretty much done by the wall management program, because that's the critical part of the project, or the critical part of the infrastructure for the road. The bridges we talked about, I showed you another one in Yellowstone. This was the same project. And in this case, we did the same thing. You can see how the piers extend out a little bit beyond the road, the bridge in this case, and we do widen it. And you look at the guardrail here, it doesn't meet current standards, and so we modified an Oregon two-tube rail system to build a new retaining guardrail system that's pretty similar, we did a lot of design visualization with this, working with the State Historic Preservation Office before we began this work. And then we widened this, and the last case we had a steel structure. This case we did pull the piers out. Hydraulically there were problems with that, and that was something we had to closely work with SHPO, and our cultural resources specialist worked with the State Historic Preservation Office to get that approved. And then this is kind of a unique situation on a lower speed area on Cub Creek. We've got log rail here. It's steel backed, and there's actually a tube of steel in the back of cut into the logs back there. And then the posts are actually simulated timber. They're actually concrete, reinforced concrete posts that have a wood texture and paint on them. And we have a lot of stone curbs wherever they exist in the parking areas and the like. We usually try and replicate that. Some of the stone actually has come out of the Camas Quarry in Vancouver, or Camas over there, for some of the work in the park. This particular site was in Yellowstone. And when we are doing the projects, we look for opportunities for enhancements as well. In this particular area, we did a slight relocation because the road was in a thermal area very close to a geyser, and we couldn't widen in that area. So we moved the road up onto a hillside, and when we were doing our design work in that area, we were climbing around up on the hill, kind of trying to decide where that road should be, and we came out to this point, and we said, gee whiz, there's a really nice view of Grand Prismatic Spring there in the Midway Geyser Basin there, and so this is a view from that overlook that we built there. And then we do some replication of historic structures. It's very expensive to use stone, and so we do use some simulated stone, concrete. We take patterns off of other stone within the park. And it varies depending on where you are in the park. So you need to fit the context of whatever the stonework in that portion of the park was, how it was developed. And so in this case, we were building some retaining walls, and they're simulated stone, and they're stained. We have some trouble with the stain on this one. We're going to have to go back in and restain it, but where we have visitors actually out of their cars, like in a pullout or something like that, we'll use real stone. But it's somewhere where people are driving by at 35, 40 miles an hour, we'll consider simulated stone. And it's kind of, I've kind of used up most of my time. I was going to go into some thermal design. It's more specific to Yellowstone, but I can do a little bit of that, or we can start doing questions, I guess, however you folks would like to handle that. Okay. The second row.
What are the transportation challenges facing Crater Lake National Park, and are there any projects being planned to address that?
There's actually one currently under construction right now, coming in, reconstructing the west entrance that was just let to bid last fall. And Crater Lake, like Mount Rainier and Glacier, has a lot of retaining walls, and that, I think, is going to be one of the driving things. I don't think that there's going to be a lot of push to widen the roadway up in that area, so I think it's probably going to be more of a preservation sort of a approach around the rim drive going around Crater Lake. They haven't actually done some of the programming and planning and inventory work that's been done in some of the other parks, so they've kind of been a lower priority in the Pacific Northwest region, or Pacific West region, and most of the work that we've done in the park there in the last 10 years has been more in access up to we've done a couple of projects going up to the loop there, and so I think at some point the park may have to do a study and determine whether they're going to limit vehicles up on that route, because I don't think they can do widening up there. Yeah. Back there? Yeah, you.
You talked a little bit about how sort of road design and the preservation of the qualities of the park are often at cross purposes. Can you talk a little bit about how sort of the pressure for access and mobility have really changed over the time that you've been at FHWA, and at sort of differences between different types of parks, like, say, Yellowstone versus Glacier or Denali, how that has changed while you've been there?
One of the things Yellowstone did, and part of it kind of depends, is how the road system operates within a given park. In Glacier National Park, it's a cross-park route, and for all intents and purposes, Glacier is really pretty much of a wilderness sort of park. Other than that park route there, and then there's also a road goes up the North Fork of the Flathead River there. There's really not a lot of road access outside that area. So, and there's Highway 2, which is a primary state route, is just on the south side of the park there, and so that's really the cross access for people. And so that's one of the reasons why Glacier Park it was easy for them to make the decision, hey, there's nothing more than a 24-foot vehicle going up and down this road, because people had alternates. When you start talking about a bigger park like Yellowstone that has 5 entrances, and the Grand Loop itself is 160 miles long, and you've got all these different resources. You've got visitor facilities scattered around the park. There's lodges at Old Faithful and Grant Village, at Mammoth, and people are staying there. It really doesn't lend itself to some sort of a shuttle system or a mass transit system. People typically spend only a day in the park. The average visitor, a lot of people stay longer, but a lot of them only spend a day there. So they may, most of them don't go out the same entrance they came in. So you really don't have a lot of opportunity to come up with an alternate way for people to see the park there. And so that kind of was given the pressure to address, and widen the roadways and make the changes that we're making in Yellowstone, whereas they made the decision not to in Glacier. And I think that the similar things are true for Mount Rainier and Crater Lake, the bigger historic road parks.
Specifically, I was sort of wondering, like internally within the park, how much of a pressure is it to say, we need to obviously accommodate to sort of the desire for people to see these parks, but also at the same time balancing that tension, like, like that map you showed of the original road weaving through there, and eventually it looks pretty straight. Like how much of attention is this sort of just like, oh, have we really disrupted it? We're just more at a whim and just sort of saying people want to see it. We need to make it easy for them.
We're making it easier for them, but it's just still a fairly. That's part of the context-sensitive design process. I think is to try and do as good a job as we can in upgrading that system. It isn't without controversy that the Greater Yellowstone Coalition would probably would rather not see a lot of the work that's going on. There are people within the Park Service themselves that are kind of torn among themselves as to what we should do. And so I think that's why it's incumbent upon us, those of us that are working in the park, to do as good a job as we can to minimize the impacts. And that's one of the driving criteria when we do a relocation or move off a segment, and that's one of the things we have to work really closely with the State Historic Preservation Office, because when you leave the alignment, you're leaving part, the original alignment, you're leaving part of that original context and that original historic district. So it's not without controversy, but you're also kind of limited. It's the flagship park, and I think it's very difficult to tell people they can't be there, or to put a sign up at the door and say only 800 people can come in this day, which is actually what they've done with the snowmobiles in the winter use plan. Is they're limiting the number of people that can come into the park in a given day, but they haven't been willing to do that yet in the summer season. And part of that too ties in with the communities around the outside that have grown up to support the infrastructure there. There's all kinds of restaurants and hotels and everything, and so now there's a very economic incentive to provide these facilities for people coming in and out of there. So it's a big it goes much beyond just the transportation system and the roads. There's a lot of driving forces culturally and within our culture and within the local communities.
Yeah, in Alaska, I know they have those puddle jumpers all over.
Yes.
What kind of air access do they have for the parks, or if they do have any?
I'm not sure. I know it's very restricted, but I don't know that it's actually prohibited in some cases. I think that typically when they allow people to do that, it's something that they control through a concession sort of a thing, where they put out bids and they say, okay, we're going to allow people to provide this service of, like with the tour boat in Glacier Bay going up in and out of the bay, that's run by a private company. And the facilities actually there, the visitor facilities, the lodge and the like, are owned by the Park Service, and the lodge and everything in Yellowstone is owned by the Park Service, but there's a company that manages it. So I think that's how they deal with it there, where they put out bids and they say, we're going to allow so many trips in and out of here, and we'll allow you to be able to do that, because you bid, and you're going to provide these types of safety things. You're going to, and it's also a way they have of controlling the impacts that might be associated with that too, and so.
In your decision-making process, do you assign kind of different weights to different criteria, and is that applied kind of consistently in all national parks, or do you change it?
I think typically it's going to change from park to park, because kind of as I've alluded to in the presentation, that there's kind of different things that they're trying to accomplish in each of the different parks, and there's some cases we use matrix sorts of decisions like that. And we also do value engineering on each of our projects as well, to try and evaluate some of the different activities there or things. But typically it's more of a kind of a balancing act that's not necessarily done on a matrix kind of a basis, on a site-by-site basis, where whoever's making the decisions in that park, will work their way through that. But we have used matrices and tried to quantify the impacts in some cases.
I'm just curious about the extent to which non-automobile use factors into road design decisions. You mentioned snowmobiles. I'm also wondering about bicycles, et cetera.
That's also another factor that's tied in with the wider road standard in Yellowstone. The park is not promoting bicycle use, but they do recognize that people want to do that, and a lot of park staff themselves ride bikes and the like, and so the lanes are 11-foot lanes, and there's 4-foot wide shoulders in Yellowstone. And some of the other parks where they're building them narrower, well, Glacier's a good example. In the what we call the shoulder seasons, the spring and the fall, when there's less visitor traffic, they'll have gates closed, or they allow bikes in the morning up and down the Grand Loop. Going to the Sun Road. So there is in that road you really can't have them working together, because of the bikes are traveling very slow. There's just no room with it's a 20-foot wide, 20 to 24-foot wide road in a lot of cases, and so the bicycles really aren't a good mix in there with the amount of traffic. I think there's like 6,000 ADT going over the pass at the peak season there, so it's just not really compatible. So in that park, they've made a decision to give them time periods to use it. In Yellowstone, there aren't really any restrictions. But that wider shoulder does help them much better. Riding a bike on the 22 to 24 foot wide roads that are in a lot of the parks is pretty scary. I know Mount Rainier. I haven't actually worked in Mount Rainier, so I can't really speak too well to how they're managing bicycles up there. But
have any land bridges been constructed over roadways in Yellowstone to accommodate for animal migration patterns or anything like that, to accommodate safety and set animal issues like that in the park?
We haven't done anything like that yet. That's not to say we won't get there at some point in the time. One of the things that in working through with the biologists and evaluating and the species like that, East Entrance Road is a good example on the current project we've got going over there. On that road, there are some major draws. It's pretty steep country, a lot of cliffs and the like, and so grizzly bears, a very, very heavy grizzly bear population in those areas. And so they do pretty much go into certain draws and like that. And in doing the road there, a lot of cases we've got retaining walls in some of those areas, and they create a barrier to the bears to go over there. So we didn't build any tunnels or anything like that, but we're building rockeries on the outside of the retaining walls in places, and working in trees and stuff like that, and shrubs, so they'll have cover to be able to get up over the walls. And that is a major factor when we start looking at a project, is that that retaining walls are nice at limiting the impact, but they do create barriers, and so we're careful in placing those and how we do that. I think there was one more back over here.
We've had several email questions from our internet viewers. And I'll maybe just try to ask parts of two of them.
Okay.
You talked about the curvilinear versus straight alignment, and I guess the viewer was asking whether it would in fact be safer from your perspective to have a curvilinear alignment, since it would encourage lower speeds. And then the other question was about whether there are limits on extensions to service roads to preserve and maintain the integrity or the value of a park.
The first question there, as far as the curvilinear alignments, there's some good examples. We did a 3R project on the Northeast Entrance Road in Yellowstone a few years back, and what was really intriguing about that is in about half of that road still, other than chip seals, they were actually running on the original pavement without overlays on that road. And of course, some parts were getting pretty badly deteriorated, and the condition of the road had a tendency to slow people down. And that puppy is only 20 feet wide. We don't have the funds to get there yet to do the reconstruction on that, so it was overlaid at 20 feet. And because it goes through some very big, broad valleys, there's some half-degree curves in there. You got a 3-mile long curve that's almost straight. People can do 90 miles an hour out there. And so, and the rangers have clocked people doing that once we've improved that. So one good thing, I guess, about that is that there is a large ranger presence, that they have a lot of rangers in the parks, and of course they get called off when there's bear sightings and people to protect the people around the bears and the like. But I think the curvilinear alignments generally help us maintain the slower speeds and keep people controlled. The second part of the question?
Road extensions or service roads.
Yeah. For the most part, I'm trying to think if I've ever actually been involved in a project that we're pretty much working on existing road system with any projects I've been involved with. They're not going to extend the road anymore into Denali. So there, as far as extensions, there aren't that. But and that's like I've talked previously. There's really a balancing point as far as, and each park manages their park and approaches their park a little bit differently, and so they kind of set the standards on the way the development and whether they're going to widen the road or not, or whether they're going to limit traffic, and so it's pretty much controlled by the local park. So, well, we've gone over a bit, but any last questions?
Time. So
Our clock is slow.
Yeah, that's slow. Yeah, I'm
Before-
showing 8 minutes over here.
I wish the students good luck finals and happy holidays. We'll be back next quarter in January. I think I'm the first scheduled speaker. So, so thank you, Craig. Very
you're
enjoyable
welcome.
today.
I do have one thing. I've got some copies of my business card up here, and then we've got a video that we produced last year called Laying Lightly on the Land that talks about federal lands highway work across the country. I've got 5 copies here, but you can email me if you'd like to get another one. Okay.
Kind of on the snowmobiles.
Mm-hmm.
Is there a program dealing with that in, say, Yellowstone National Park, in terms of providing them access or deciding on the route?
Well, they run right on the roadways themselves. They don't go off the roadways. They don't go off the roadways at all. They're only, and that's part of the thing. It's real interesting how the different administrations have controlled it, because the park had gone through and EIS and basically was going to stop snowmobile use in the park. Well, the administration